Good evening, guys. I hope everyone is doing well and stuff. Um, Welcome back if you're joining us for the first time. Welcome if you're joining us for the second time, and welcome if you're joining us for the first time. Um, my name is Rutendo. I'm one of the tutors here at the Learning Space, and I'm going to be taking us through the second part of our 2024 paper 2. Okay, so our first question for today is this one. We have question 4, it's another analytical question, and we read, in the diagram, there is a circle center. Oh, sorry, this is a Euclidean / analytical. So it's kind of both of them mixed together. There's a circle center. The center cuts the axis at N. So we have a circle with a circle center there. It cuts the axis, the x-axis at N, right? ST is a tangent to the circle at P, which is there at 3 and 9. And R, we have, oh yes, we have R is a point on the circle with D being greater than 0. So D is going to be a positive number. And L lie on the circle. O and V are the x-intercepts of PL and RL, respectively. First question is, what are the coordinates of L? Right. So in this diagram that we've been given, we have a line PL and we're given its midpoint, right? So we're given PL, here's PL, and we are given P and the midpoint of P. And we're going to use that to find our L, right? So what does our midpoint formula say? This is our midpoint formula here. Our midpoint formula says that our midpoint is x1 plus x2 over 2 will be y1 plus y2 over 2, right? And so our midpoint gives us a point. So it gives us an x value and a y value. It gives us an x and a y value. And in this case, the x and y values are 1 and 3, right? And so that means that if I look at this as point 1 and this as point 2, then that means my midpoint is going to be n, and I can substitute in the values that I know. So if I'm looking at p as x1, I'm going to say, what is this going to be? 3 plus x2, which is what we're looking for here. On L, we're looking for x and y. And this is going to be divided by 2, right? And my y version of that is going to be 9 plus y over 2, right? Now my midpoint tells me what these two numbers are going to be. They tell me this is going to be 1 and this is going to be 3. And so I can make two equations with that. I can say 1 is equals to 3 plus x over 2. And I can say 3 is equals to 9 plus y over 2, right? And then I can multiply both sides by 2 here, right? And so I'll have 2 is equals to 3 plus x. And I'm solving for x here, so I'm going to take that 3 to the other side. It'll be 2 minus 3. And so x is going to be equal to minus 1. And then for y, we're going to have multiply both sides by 2 here. We're solving for y, and so we're going to have 6 is equal to 6 is equals to 9 plus y. And so y is going to be equal to 6 minus 9. And so y is equal to minus 3. And so the coordinates for L are going to be that x is minus 1 and y is minus 3. Okay, so that's my L, going to be minus 1 and 3. Okay, next question says, I'm just going to move this down, and then I think I have a diagram. Yes, I do have a diagram. Let's move that here. Okay, so we've just now found that y is equals to minus 1 and 3. Maybe we can put that on the diagram as we go. Okay, so the next question is, determine the equation of ST, the tangent ST to the circle at P, right? So we've found already y to be minus 1 and minus 3. So we can keep that there. Okay, we're asked for the equation of ST. ST is up here, right? And they said it's a tangent, right? What do we know about Euclidean and tangent? And we're given the circle center as well. So that's another hint. They said this midpoint is the circle center. So we know that if I have a line going through the center of the circle and it meets the tangent, that it makes a 90-degree there. So that means that this over here is a 90-degree right there between PL and ST. It's a 90-degree. And what do we know about lines that have 90 degrees? We know that they are perpendicular, and perpendicular lines have conflicting gradients, or we say they have negative converse gradients, right? So the gradient of ST multiplied by the gradient of LP will give you -1, right? This is for perpendicular lines. Okay. Yes. So the reason why we can say this, right, is because of tan perpendicular to rad. The tangent is always perpendicular to a line that's from the center to the circumference, which is the radius. Okay. And so we can now say, um, we can find this gradient of, let's find the gradient of PL. So the gradient of LP is going to be equal to y2 minus y1 over x2 minus x1, right? And so that gives me y2 minus y1. Let me say that this is my 2 and this is my 1. Let's just erase this. Okay. Let's say that will be 9 minus 3 over um, over 3 minus 1, right? So it ends up being 9 plus 3 over 3 plus 1, which gives me, what does this give me? This gives me 12 over 4, which ends up being 3. So the gradient of PL, sorry, is going to be 3, right? And so if I want to find the gradient of the ST, I'm going to multiply it by the gradient of LP. So we're going to have the gradient of ST is going to be equal to -1, or we can say, let's write it out as a proper equation. The gradient of ST multiplied by this 3 is supposed to give me -1. And to get rid of this 3, or to get the 3 to the other side, I divide by 3 on both sides. And so I'll have a gradient of, so gradient of ST is going to be -1 over 3, right? So if I'm writing it as y is equals to mx plus c, my y is now equal to -1/2x plus c. Now we know that to write out an equation, we have to know what the c is, like what's that value, and that is going to be, we have to find it using a point that we have on our line, and we have this point P on our line, it rests on that line, so we can substitute the x and the y for that point P into this and find what my c is. Okay, so I'm going to substitute in that y, so 9 is equals to -1 over 2, x is 3 plus c, right? So 9 is equals to -1 over 2 multiplied by, oh, sorry, let's not write it down like that. Let's say y is equals to, oh, sorry, this is 3. Y is equal to, is going to give me -1 plus c, and so c is equal to 10. And so my full equation is going to be y is equal to -1 over 3x plus 10. Okay, so that is my equation for that line, for that tangent that we have there. Okay, so now let's move this down. Okay, then the next question says, show that, we know this point over here is -1 and -3. Okay, show that the equation of the circle with center M is this. So when they say show that, you are trying to, you can't use this yet because they're asking you to show that it's equal to that. So you can't use it in your thing and then manipulate it or whatever, right? we are trying to find the equation of this circle that we have here. Now we know for the equation of a circle, it's going to be x minus a all squared plus y minus b all squared is equals to the radius squared. And this a and this b correspond to your center, right? So a is the x value for the center and b is the y value for your center. And so in this case, our center is M, and that is at 1 and 3, which means that my equation is going to have x minus 1, right, squared plus y minus 3 squared is equals to r squared. Now, we don't know what that r is, right? But we can find it similar to how we found c in this case, right? Here to find c, we substituted in a point x and y, right? The x and y values for a point. We can do the same here to find my missing r, right? So I'm going to substitute in, let's substitute in 3 and 9, right? So this point P that's on the circle. So any point on the circle, you could have used R, but we don't know what D is, but you could have used L as well. Any point on that circle you can use. You can't use the lines though. So you can't use, if you had this, you can't use that. Okay, so let's try and substitute in 3 and 9. So x for that 3 and 9 is going to be 3 minus 1 squared plus y is going to be 9 minus 3 squared is equals to r squared. And so now we're going to um, find what this is. This is 3 minus 1 is 2 squared plus 9 minus 3 is 6 squared is equals to r squared. So this gives me 4 plus 36 is equals to r squared. R squared is equals to 40. And so we can write our equation now as x minus 1 squared plus y minus 3 squared is equals to 40, because we need to keep it as r squared, so we can just keep it as 40. Okay, now we look at what we're trying to find. Okay, we want to show that it's equal to this, but I can see that there's no brackets here and there's nothing on the other side of this equal sign. So I need to first expand out this x minus 1 and the y minus 3. So it'll be x minus 1 plus y minus 3, y minus 3, and y minus 3 is equals to 40. We'll move the 40 that side just now. So x minus 1 gives me x squared minus 2x plus 1, and then this gives me y squared minus 6x minus 6y, sorry, minus 6y minus 6y plus 9. And I'm going to say, yeah, let's move the 40 there already. That's fine. Okay. And then now I'm trying to I can see in this one that they asked me to show whatever, they wanted me to write x and y. We have x squared and y squared next to each other. So I'm going to move x squared and y squared to be with each other. So x squared plus y squared. Then I have minus x, minus 2x and minus 6y after that. So minus 2x minus 6y. And then 9 minus 40. Oh, sorry, I feel like I lost something there. Oh, yes. And then there's this 1. So we have numbers here. We have 1, we have 9, and we have 40. 1 plus 9 is 10, and then 10 minus 40 is going to give me 30. So minus 30. 10 minus 40 is going to give me minus 30. Okay. And now we've proved that this, the equation for the circle of the center ends up being this. So we first started off by writing just the general equation of a circle, right? We found the center of the circle, then we found the radius, right? After we found the radius, we then were able to write the full equation, right? And then we expanded that equation to give us the 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 expression we were trying to solve for. Okay, so that is how you would prove that. So you'd first write the equation of a circle, and then try to make it look like what they asked you to show. Okay. Then they asked, next question is, show that D is equal to 7. Okay, let's move this down a little bit. Show that D is equal to 7. So we know that this point over here, oh no, let's not do that. We know that D is at R, right? We know that D is over here at R, right? And we want to show that D is equal to 7. We know that this point over here is -1 and -3. We are trying to find that D is equal to 7. Okay, how can we do that? How can we show that D is equal to 7? Well, we found the equation of our circle, right? And that point lies on the circle. So the equation of our circle, we found it to be x minus 1 squared plus y minus 3 squared is equal to 40. That's what we found our equation to be. And we already have a y value here. So you could use this equation or you could use this equation. So they actually very nice by saying show that it's equal to this, because then you can still use this in the next question. So even if you didn't get this, you can still use it in the next part. And we didn't change anything from here to here, right? We didn't change anything from the normal equation of a circle to the expanded version. We just expanded out. So nothing has changed. So you can use either one of these for this next question. But I'm going to use this one because it looks nicer. I'm going to substitute in a y value of 1 because we're looking for D, which is the x value, when my y value is 1. So I'm going to just put in x minus 1 squared plus y, which is 1 minus 3 squared, is equal to 40, right? And so x minus 1 squared plus, this is going to be 1 minus 3 is minus 2, right? Minus 2. This is going to be, what is this? Yes, this is going to be minus 2 squared, which is going to be 4 is equals to 40. Okay, if we expand this out, gives me x squared minus 2x plus 1, and then I'm plussing 4, and then I'm going to move this 40 to that other side. So I'm just going to say, or actually, no, let's do it the other way. So instead of doing it that way, let's just rather move the 40 to the other side. Let's move the 4 to the other side. So we'll have x minus 1 squared is equals to 40 minus 4. So that's equal to 36, right? So x minus 1 squared is equals to 36. And then we can square root both sides, right? So let's square root both sides. We will square root and square root to get rid of this square. And so I'll have, and then we have to add a plus minus whenever we introduce a square root. So x minus 1 is equals to plus minus the square root of 36, which is 6. So x minus 1 is equals to plus minus 6, right? And so x is either equal to minus 6 plus 1, or x is equals to plus 6 plus 1. So x is equal to either minus 5 or x is equal to 7. How do we know which one to choose? Let's see what they said at the beginning of the question. At the beginning of the question, they said D must be greater than 0, right? They said D must be bigger than 0. And so we need to use that. We need to choose whichever value of x or D. So this is basically D. So D is equals to minus 5 or D is equal to 7. That is greater than 0. So this one would not be applicable. So not that one. And so in our case, D would be equal to 7. Okay. And it's so nice that they're saying show that it's equal to that, which means that even if you don't get it, you can still use it in the questions that come after. So now you can assume already, you can walk or you can go to the next question, assuming that this is 7 and 1. Okay, so you don't necessarily need to have done this correctly. So even if you made a mistake and you didn't end up getting D equals 7, use the fact that D equals 7 for the next few questions. Okay, okay. And then our last question would be, oh no, second last question. Second last question is show the size of L. So now we are looking at this diagram, and we're asked to find the angle L, which is this angle over here, that angle inside this triangle that's inside the circle, right? We're asked for this, let's say this is theta, right? And we've got a bunch of stuff that we could do, but I'm going to use our famous gradient is equals to tan of theta, right? But we can't just do it directly because now here we have two things here. So I am going to try and find the angles in this triangle, in this small triangle here, and try and make that work to find my theta. Okay, let's see how we can do that. So we can find this angle here. Let's call it alpha, because we know that we can find the gradient of PL, which we already have. We found it to be 3, right? And we can find the gradient of RL, right? And find this angle here. So let's first find alpha. So gradient is equals to tan of alpha. We're trying to find the gradient of alpha. So we found that gradient to be 3 is equals to tan of alpha. What does your alpha equal to? What do you guys get as your alpha? So you'd have to do that shift tan of 3, and you'd get alpha as 71.565 degrees, right? And then now let's try and find, let me just move this to the side. Okay, so that's our gradient for alpha. We now know that that angle over there is going to be 71.565. 71.565. And now I'm looking for this small angle over here. Let's call that beta. Let's first find the gradient of RL. We know that R is now 7 and 1, and L is still -1 and 1. So I'm going to find the gradient of RL is equals to y2. I'm going to say 1 minus minus 3 over 7 minus minus 1. So that gives me 1 plus 3 over 7 plus 1, which is equal to 4 over 8, which is equal to 1 over 2, right? And so I can use now this gradient is equals to tan of beta, right? And so we are looking for, we have our gradient is a half is equals to tan of beta. What is my beta equal to? If this is tan minus 1 of 1 over 2. What is beta equal to? Beta is equals to 26.565, right? Or 567, depending on how you round it off, but it's okay. We can keep it as this, right? So now we know that this is 26.565. I want to redraw this kind of a little bit better. So if I look at, this is my x-axis, I have an angle here, and I have an angle going like this. I have just found that this angle over here is 71.565, and I've just found out that this angle over here is 26.565. Okay, I could use, there's two methods to do this. You can use either exterior angles of a triangle, or you can use a straight line. So first way, using exterior angles of a triangle, you know that if you have a triangle, if you look at this angle, it's going to be the sum of these two angles added together, right? So if this is A, this is B, and this is C, then C is going to be A plus B, right? And so I can say, oh no, wait, yes, sorry, before we get there, we already know that this angle on the inside is going to be 26.565 because of vertically opposite angles. So you can say, you can write it out as angle OVL is equals to 26.565 because of vertically opposite angles. Okay, you'd also need to name these. So sorry, I forgot to name these top ones. So this one where we found our alpha, this would be POV. Haha, POV is 71.565, and this beta is RVN is equal to 26.565. So you just need to make sure you say that, you state this, right? And then we said OVL is going to be 26.565 because of vertically opposite angles, right? And so if I'm using the exterior angle of a triangle, I know that angle L, so angle, we can say 71.565 is going to be equal to angle L plus 26.565. And so I end up finding my angle L to be 71 minus 565, 71.565 minus 26.565, which will be equal to 45 degrees. Or, and this would be using exterior angles of a triangle. Or I can say, um, yes, I can find this angle here. So that angle would be called, what do we call that angle? We would call that angle O, no, not angle O, VOL. We could say angle VOL is equal to 180 minus that 71.565 because of angles on a straight line, right? So this gives us 108.435. Thank you, Nicole. Right? That'll be the degrees for this VOL, this angle in the inside here. Ooh, this angle on the inside here. Oh no, don't change color. It doesn't matter. And now I have a triangle. So we can do in angles in a triangle. I can say angle L is going to be equal to 180 degrees minus 108.435 minus 70. Oh, sorry, not that one. Minus 26.565. Minus 26.565. And this should give you around about 45 degrees as well. It simplifies to 45 degrees. Okay, so we found the size of L by first using the fact that we know the gradients of these lines that we have here and here, right? And finding the angle of inclination using gradient is equals to tan theta. Then you can either use exterior angles of a triangle, or you can use angles on a straight line to find, and then angles in a triangle. Sorry, I forgot to say here, angles in a triangle to find what your L is going to be. So L is going to be 45 degrees. Okay. And then okay, now okay, I don't see any questions yet. So that's great. Now to the last analytical slash Euclidean. We have we are asked to prove, let's just move this down here. We are asked to prove that RT is perpendicular to PT, or PT is perpendicular to RT. Let's make this a little bit bigger so that we don't have to strain to look. So we are asked to prove that PT is perpendicular to RT. Now, they hadn't drawn RT at the beginning, but we can draw like a fake line there. Okay. Okay, so they said TR is a tangent, so they actually make this is a tangent at that point. So they said TR is a tangent. We know that this point is -1 and -3. We now know that this angle is 45 degrees. And we are trying to prove that PT is perpendicular to RT. Okay, and so we're going to have to go, this is 3 marks. Okay, so not too much work, but you have to think a little bit. Okay, so, sorry guys, just give me 1 second. Okay. Oh, it's both has got it. Okay, so first thing that we notice is that I see these 2 tangents and I automatically think tangents from the same point, right? Right? And we know tangents from the same point have equal angles, okay? Have equal lines, which means that this angle over here and this angle over here are going to be the same. Okay, okay, I also have tan chord theorem working here for me. Tan chord theorem says that if I have a circle and I have a tangent, and from that tangent there's a chord, the angle that the chord makes with the so the angle, there's a chord, right? So we have a chord here. The chord is just a line from one point of the circle to another. The angle that the chord makes with the tangent is going to be the same as the angle that is made by the 2 lines that come from the chord. So is equal to that. So that's basically what tan chord theorem says. And I think I can see a tan chord somewhere here. I can see a tan chord here, right? So I have this tangent and I have this chord, right? And there's an angle that's coming from the chord here. So this angle, and the chord is making 2 lines that intersect at another point here, which means that this angle over here, that L, is going to be the same as that angle P, right? Because that's a tan chord theorem. So let's write it out. How would we write that out? We would say, I'm just going to erase all of these. We would say, um, again, they were so nice as to tell you that they wanted, oh no, they didn't ask you to show, sorry, they just asked you what is angle L, sorry. So, but anyway, we can say that angle, this is T P L, right? TPL is equal to 45 degrees because of tan chord theorem. You could also have found there's another tangent, right? There's this tangent here, and it also has an angle, and it also has a chord that's making an angle at the circumference, which is going to be that same L. So you could have also said that TRP, sorry, I wrote this wrong. It's TPR, not TPL. TPR. Yo, why did I put the angle on the P? There we go. TRP is also equal to 45 degrees because of tan chord theorem. So both of those could have worked, but either way, you've just now proved that, okay, if you, let's say, okay, let's ignore the second one. Let's say we proved, yeah, let's ignore the second one. Let's say we proved this one, right? We just now found that that angle P is equals to 45. We can therefore say TRP is also equal to 45. And because it's an isosceles triangle, but we can't say isosceles triangle, we have to say What do we say for if we want to prove or if we want to show that we're using isos triangle? What is the reason that we use? We can't say isos triangle. What do we say to prove or to you when we're using isos triangle? What is the reason that we use? Perfect. Yes. So we can say angles opposite equal sides. Perfect. Okay, so that would be our reason. You can't say isos triangle. Okay. Yes. Okay. So now we've now proved that P and R or P that yeah, this angle P and this angle R are the same. And therefore we can say that angle T is equal to 180 minus 45 minus 45, right? Because of angles in triangle, right? And then we can say uh, T is equals to 90 degrees. Therefore, PT is perpendicular to RT. Okay, and so that is our proof. Moho got it a long time ago. It looks like we're slow, guys. Okay, cool. So this is how we would prove that RT is perpendicular. So you just have to work with stuff because you found L. You know that I'm gonna have to use this value that I got somewhere, and I use it to prove that these are the same and they're both 45, and I can find that that's equal to 90, which means that, oh, sorry, we didn't say why this is an isos triangle. So the first thing you would say is you would say PT is equal to TR, right? And you'd say 10 from the same point. Sorry, so that's step number one before all of this, to say that those two are the same so that we can use isos triangles. Okay. Okay, cool. No questions? I think we can move on to some trig. Okay, so now trig can be the best subject ever, the best topic ever, or like the scariest topic ever. But because you've been doing it for so long, I feel like it has to be one of the best ones because you've been doing it for so long. Okay, so the first question says, in the diagram, OP is given with P being 3, minus 3 and 4, and KOP being A. First, they asked determine, without using a calculator, the value of cos A. Okay, so what I want you to do, you know that when you have this kind of diagram being drawn, you have to make a triangle, right? If you're given two coordinates, or you give it a coordinate and you have kind of like a line that's drawn from the center to the coordinates, you have to make a triangle so that you can have an angle. So you are always going to join it with the x-axis. So always join it with the x-axis. If it was here, you would join it down. If it was here, you would join it down. So always join it to the x-axis. If it was here, you join it up, right? So that it joins with the x-axis like that. But in this case, we were just joining it up. Okay, and we can draw the size of this triangle. You know that if this coordinate is at minus 3 and 4, right, it means that it's moved this way 3 times and it's moved down 4 times. So you can write this as 3 and 4, but because they're in the negative x-axis, it has to be minus 3 and minus 4. And then you can use Pythagoras by saying 3 squared plus 4 squared is equals to the hypotenuse squared. This gives you 9 plus 16 is equals to the hypotenuse squared. And so 25 is equals to the hypotenuse squared. So your hypotenuse is going to be equal to 5. And your hypotenuse is always positive. No matter where in the quadrant it is, on your Cartesian plane it is, it's always going to be positive, right? So in this case, it's going to be 5. And now I know that they gave you this whole angle as A, but you're going to treat it as this, as if this is A, right? As this little angle, just that little bit is A. Okay, you don't have to worry about the fact that it's going all the way around. Okay, so we are now going to say we're looking for cos A, and now you can just use your SOHCAHTOA, SOHCAHTOA, to find what cos of that angle A is. So if you were to redraw this triangle, it would actually look like this, right? With your A over here, this is -4, this is -3, this is 5. So cos is adjacent over hypotenuse. And so I can say adjacent in this case is going to be -3, and then my hypotenuse is going to be 5. Okay, so this is how we would find cos of A. Okay. And then they asked, oh no, I was supposed to put a diagram of this. Let me bring this diagram down. Okay. And then they asked, oh sorry, it's gonna load now. And then they ask, find cos 2A, right? Let me just copy this one that I have here so that I don't have to redraw a bunch of stuff. Okay. Then they said, find cos 2A. Now, some students will say, okay, bet, I can just move the 2 to the outside and then we're good. But that is not how we work with trig functions. So they're not going to be the same as like brackets and just taking things outside. You're going to have to find another way to write this cos 2A with just A, without this 2A in there. Okay, so in our case, I am going to say, I'm going to try and make it into one of these identities here, right? We already have what cos A is equal to. We just found it here to be -3/5. So I preferably want things that have cos A so that I can just put in -3/5 there. And I think I'm going to choose this last one because it's nice and easy. It just has cos. I don't have to find sine at all. Okay, so I'm going to say cos of 2A is the same as 2 cos squared A minus 1, right? So instead of having 2 alpha, I'm going to have 2 cos squared alpha minus 1, okay? So I can write this as 2. We already know that cos A is -3/5, so I can write this as -3/5, and I'm going to square that, right? And -1, okay? And then I can solve this by saying, you can just put this in your calculator. You don't really have to worry about writing down all the steps. So in this case, my answer is going to be, if I put this in my calculator, it's going to be -7/25. That's my answer. Okay, but you could have used this one. Okay, let's try and find, let's see, there's the next question. Okay, the next question has something else. But let's try and see what sine, let's maybe try, yeah, just to show you that any of them could have worked. Let's try this first one, cos squared alpha minus sine squared alpha. So we can write cos 2A as cos squared A minus sine squared A, right? We already found cos 2A is 3/5, and I'm going to square that, minus sine is adjacent over opposite over hypotenuse. My opposite is 4. My hypotenuse is 5, so it'll be -4/5 squared. And that should also give you -7/25. Okay, so it's the same thing. You're not really doing anything too different when you're using a different identity. So you should get the same answer. Okay, and then let's see if I can join these two. Don't take the 5. Okay, no, it's fine. Let's move this down. Okay, my next question is sine A minus B if sine B is equal to that. Now, what does that mean? What do you mean sine A minus B? We just had A. There's no B on my graph here, on my plot here. So how am I supposed to find sine of B? I think we're going to have to expand this. Oh, but we're given sine of b. So let's see. Okay. I am going to rewrite this. This is a compound angle, right? So I'm going to rewrite the sine a minus b as using this compound angle. So it's going to be sine a cos b minus cos a sine b. That's the same as this. I've just rewritten it using the compound angle formula. Your cos b, right? I know sine A. I can find that from my thingy. We already found it. But I don't know what cos B is. I know what cos A is, and I've been given sine B. They gave it to me. And they gave me this thing here. And that usually means that I need to draw a diagram. And so let's draw that diagram. They're telling us where B is. Okay, yeah. So that means I'm going to have to draw another diagram. First of all, they give me sine is 4 over 5. And I know sine is, sometimes Candace thinks O over H, right? And so I can say, can draw my diagram. Okay, first of all, sine is positive in this configuration that we're looking at. So its sine is positive here and here. And then beta is between 90 and 360. So we know our angles are 0, 90, 180, 270, and 360. So we can say if it's between 90 and 360, it's going to be here, here, or here. So our quadrant that we're working in is our second quadrant. So if I was to draw a diagram, I'm drawing it like this, right? And my beta is going to be here. And they said that sine is going to be what? 4 over 5. We know sine is opposite and opposite over hypotenuse. Opposite is 4, hypotenuse is 5. And then with Pythagoras, you can find that this is going to be 3. But because it's in the negative x-axis, it's going to be minus 3, right? So it's the same as our triangle here. It's basically the same thing, right? And so now we have a triangle for sine B, for B. So we can find cos B. So let's look at this. This was our triangle for A. This is our triangle for B. So let's look at this. We're looking for sine of A. So we look at this diagram here. Sine is opposite over hypotenuse. In this case, my opposite is minus 4. So I'm going to write it out as minus 4 over hypotenuse, which is 5. That's fine. Cos B, now we're looking at B. B, cos is adjacent over hypotenuse, so minus 3 over 5 minus cos A. We already have cos of A is going to be, we found it before, to be minus 3 over 5. And then sine of B, which we already given here as 4 over 5. Right. So we're going to write this as 4 over 5. And then again, you can just put this in your calculator, or you can do it the difficult hard way. But you should get, if you multiply these two together, the first two together, you should get 12 over 25 minus, oh, is it going to be minus? Oh, yes. So here we have minus 3 and minus there, so it's just going to be plus 12 over 25, which is going to be 24 over 25. Okay, so first of all, we realize that we are going to have to draw another separate triangle for B. And so we first looked at where is sine positive. Sine is positive here and here. And then my beta was between 90 and 360. So it was either here, here, or here. And so to the category that the quadrant that satisfies both of those is going to be this one. And so we draw our triangle with our beta there. We knew that sine beta was 4 over 5, which is opposite over hypotenuse. So opposite hypotenuse is there. Okay, and then we said that we can find this minus 3 just by using Pythag. And then because we had already this angle with A, we could find B, cos A, cos B, and just write it out normally. Okay, so the first thing you see is the sine A minus B, and you're just like, I have no idea what that means because I don't even have a B up until this point. then you see that I can break this down into a compound angle, right? And that just leaves it with just A's and B's, not A minus B, or right? And so that's where we can then start from. Okay, I see a lot of you were getting the question right. Well done, guys. Okay, and then we have this, our wonderful, wonderful thing here. Okay, then our next question says, I have this, and I would like to express cos alpha in terms of P. Let's just move that all down. Okay, so I'm given cos alpha is equal to P, right? Now, this doesn't have a quadrant and whatnot, whatnot. They don't tell us that P is between this and this, so we can't draw a diagram here. So this is not where we draw a diagram. Sometimes they'll give you cos something is equals to P, then you have to put it over P over 1. Then you have to draw your triangle with a P or whatever, right? But this is not the case because they haven't given us P is between this or alpha is between this and this. So we can't draw a triangle there. We have to try and express the following expression in terms of P. So we're trying to write all of this in terms of P. But oh, this looks so complicated. Okay, let's see. First of all, in my bracket, I have alpha divided by 2, but in my expression here at the top, it's just alpha. So I'm going to have to do something to change that alpha divided by 2 into an alpha because I can't do anything. I can't compare it to P until it's just alpha. Okay, so I'm going to first start off by changing this cos alpha over 2 minus 45 into into its compound angle because it even has a 45, which I can't really do anything with because I know cofunctions and I know like reduction angles, and that is not one of the reduction angles or the cofunctions, right? So I'm gonna have to first find a way to express this in terms of a compound angle. You could, what could you do? And try to see how else you could do this. No, no, no. Okay, we'll try. I'll show you another one now. But yeah, let's try and do this. Or I kind of see this over here. This is sine of an angle and cos of an angle. So I'll do it in two ways. So this is method one. I think method one is a bit shorter. And then method two, I'll do on the side. So first method is I know that sine of 2 and an angle is equals to 2 sine theta cos theta. So sine 2 alpha is equals to 2 sine alpha cos alpha. Here I have cos alpha, sine alpha, same thing as this part. So I'm going to move this to that side and say sine 2 alpha over 2 is equals to sine alpha cos alpha, right? I can replace, in our case, alpha is, or this alpha is equals to, okay, this makes it a little bit confusing, but alpha here is equals to alpha over 2 minus 45, right? This alpha here. So I can replace this top part with sine 2 alpha over 2, with whatever the alpha is in here, right? I can replace it with this. So let's do that. So I'm going to replace that top with sine 2 times the angle that I had here, which was alpha over 2 minus 45. And that's going to be over, oh, this is all over 2 divided by 2. Okay, this divided by 2, this sine 2 alpha over 2 minus 45 over 2 divided by 2 is the same as timesing by 1 over 2, right? So tip and times is the same as timesing by 1 over 2. So I just end up with sine of alpha, sine of 2 times, sorry, sine of 2 times alpha over 2 minus 45 over 4. Okay, so I haven't found alpha yet. I'm just still here. I just said that we were replacing this cos alpha minus cos alpha, sine alpha minus cos alpha with, I'm replacing this with sine 2 alpha over 2. Okay, and that's what I've done. And then I said, if I'm saying this sine alpha over 2, which is this, and I'm dividing that by 2 because that's what it was here in this configuration, then that means that it's just going to be times by 1 over 2 because you tip in times, which gets you here where we are now. Okay, and now I can multiply that 2 in. I'll have sine of 2 alpha, 2 times alpha over 2 is just alpha minus 90 over 4. Okay, now sine alpha minus 90 kind of feels familiar, but it's not really what we know in terms of cofunctions, right? Because our cofunctions say that it's going to be, our cofunctions say that it's supposed to be 90 minus something or 90 plus something. So this is not at our cofunction level yet, but we can change it to our cofunction level. So this sine of, I'm just going to move here, sine of alpha minus 90 can be rewritten as sine of negative 90 minus alpha. So I'm just taking out a negative, right? And we know that the sine of a negative angle is just going to be negative sine of 90 minus alpha. Okay, the long version of this, sine of a negative angle, sine of a negative angle is just going to be, we're going to add 360 to it, right? So if I have sine of minus 40 degrees, you'd have to plus 360 to it to get it to a normal angle, and it'll end up in this realm where sine is going to be not positive because it's cos. So you'll end up just with having negative sine of that angle, whatever angle you were looking at. Okay, so this gives me minus sine 90 minus alpha, and this is one of our cofunctions. If I look at 90 minus alpha, it lands here. So that's just going to be negative cos of alpha. And now I'm putting it back in here. So that's going to be, we now just found that sine of 90 minus alpha is the same as negative cos alpha. Okay, I'll do it in the other way because this one is a little bit confusing. But this is going to give me minus cos alpha over 4. And we know cos alpha is p, so this is just going to be minus p over 4. Okay, so if you got minus p over 4, that's great. Okay, I'm going to do it using the other method so that you guys aren't too confused. Okay, so the other method, which I feel like is a little bit longer, is I'm going to change this cos alpha over 2 and sine alpha over 2 into compound angles. So this one and this one. Right. So let's change that. This is method 2. I'm changing it to be these compound angle formulas. And compound angle formulas means that this is going to turn into, the first part is going to be cos of alpha over 2 minus, oh, sorry, not minus, cos of alpha minus 2 sine, sorry, not sine, cos 45 plus sine of alpha over 2 sine 45, right? And then I'm going to multiply that with the sine compound angle. So breaking that down, it'll be sine of alpha over 2 multiplied by cos of 45 minus cos of alpha over 2 sine of 45. Okay, right. And this is all going to be over 2. Okay, now I'm gonna make this into numbers because I don't want to work with these. These all are equal to root 2 over 2. So if you look in your calculator and you put in cos 45, which is a special angle, which you should know what it is going to be root 2 over 2, and so is sine 45. And that's also going to be equal to root 2 over 2. Okay, I'm gonna change all of those. So it'll be cos of alpha over 2 times root 2 over 2 plus sine of alpha over 2 and root 2 over 2, right? And then sine of alpha over 2 root 2 over 2 minus cos of alpha over 2 root 2 over 2. And that's all going to be over 2. Okay. Now I have a common factor in all of these, like common factor here, common factor here, common factor here, common factor here. So I'm going to take out a common factor in the first bit of the thing. So this first bracket, if I take out a common factor of root 2 over 2, I'll have root 2 over 2 cos alpha over 2 plus sine alpha over 2, right? And then I take out another common root 2 over 2, root 2 over 2, sine alpha over 2 minus cos alpha over 2. Okay, and this is all over 2. Now these end up being multiplied by each other, this root 2 over 2 and this root 2 over 2, and that should give you a half. If you say root 2 over 2 times root 2 over 2 in your calculator, that gives you root 2 over 2, okay, root 2 over 2, I'm just checking, times root 2 over 2, that's going to give you a half, right? So I'm going to have a half. Now, what do you guys notice about these two brackets? I need you to tell me what you notice about these two brackets before I go further to write this bracket. What is going on there? What do I have in those two brackets? Dots. Yes, I have difference of t-squares because I have a cos theta over 2 plus sine theta over 2 and sine theta over 2 minus cos theta over sine theta over 2. So this is the same. You can swap these around and it'll be the same because when you're adding, it's the same. So you effectively have a dot, right? But it's a dot in this direction, in this order. So it'll be sine alpha over 2, oh, sine squared alpha over 2. Sorry, my mistake. So it'll be sine squared alpha over 2 minus cos squared alpha over 2. And then that'll be a half times a half over 2. So I combine these by multiplying them together to get a half, which is where this half came from. And then I did dots here. This is dots to break it, to make it into one bracket. Okay, now I lost my formula sheet, but this looks a little bit familiar, right? This looks like something that we've seen before. We've played these games before. So this sine squared theta, cos squared theta, this looks very familiar to something that we've seen before. And it's kind of like dots means difference of two squares. This is difference of two squares. Difference of two squares is that thing that says if I have x squared plus x squared minus 4, x squared minus 4, you can break that down into x minus 2 and x plus 2. Oops, sorry. You can break that into x minus 2, x plus 2, which is what we have here. We have that plus, and then this is minus. So that's what dots is. Oh, sorry. So I was saying this kind of looks like this. What is this? This over here. Except they're swapped around and the cos is negative. So I'm going to take out a common negative, take out negative, right? And when I take out a negative, these end up being swapped around, right? So now I'll have negative 1 over 2, and that'll be equal to cos squared alpha over 2 minus sine squared alpha over 2 all over 2, right? Now I can replace this with a cos of that double angle, right? So I can now replace this with negative 1 over 2 with cos of 2 times alpha over 2 because it's the same format, and I'm just replacing it with that. And I'm going to put that over 2. And then I'm going to have, if I do negative a half over 2, that just gives me 1 over 4. So it'll be cos 2 times alpha over 2 over 4. If you put this in your calculator, sorry, minus cos 2 over 2. Okay, then we multiply that 2 in. That'll be 2 times alpha over 2, which is just going to be alpha. So minus cos alpha over 4. We are told at the very beginning of the question that cos alpha is equal to p, right? And so we can change this to be equal negative p over 4. Okay. So for both of the methods that we did, we realized that first of all, what we're given in terms of p is cos of just alpha, not cos of alpha over 2 or whatnot. So we had to find a way to get rid of this alpha over 2. And to do that, we either method 1 was to was to was to okay, method 1 was confusing. I'll give you that. It's a little bit like tricky because you have to like think a little bit. Method 1 was to uh, merge this sine and cos using sine 2 theta is equals to sine 2 alpha is equals to 2 sine alpha cos alpha. If you understood this method, perfect. That's why I was saying method 1 is a little bit shorter because if you know that, then you can you speed run the rest of the thing. But you also have to know your co-functions and all that. Method 2 is a lot easier to follow. It feels a lot more logical because you say, okay, this is not what I'm looking for, and it is a compound angle. So I can break it down into my first compound angle and my second compound angle. Then I have a bunch of sine and cos 45s, cos 45, sine 45, cos 45, sine 45, which are all equal to 2 root 2. All of these are equal to 2 root 2, right? When I get to here, then I can take out a common 2 root 2 from both of these brackets. So I took out a common 2 root 2 there, and I took out a common 2 root 2 there. And when I multiply those together, because now this is all just being multiplied by each other, I got a half. And then I also noticed that this is a dot. This is a difference of 2 squared. These two brackets are the same. One of them just has a plus, one of them has a minus. So I could rewrite it as a difference of 2 square, right? And so when I rewrite it as a difference of 2 square, I get something that's similar to this trig identity that I have on my formula sheet. This cos squared alpha minus sine squared alpha, but it's opposite. It was opposite when we put it into difference of two squares. So we had to take out a negative to get it to be the same format as what we have there. And so we'd end up with our cos 2 of that angle, and then we could multiply in 2 to get rid of that a half, and then we ended up here. Okay, now this question is only out of 4 marks. If you have spent 5 marks, if you've spent 5 minutes on it and you're still not understanding, move on. You'll buy another one. You'll just go on to another question, and then if you have time, you come back to it. Then, because then you have time to think at the end of your paper. But if it's too confusing and you're like, I have no idea how to get to there, you can try it, try and get an understanding of what's going on. And then if you get stuck, or if you get here and you're like, I don't know where we're supposed to go from here, then you pause, maybe try another question, come back, then you'll say, actually, I can take out a comment. You'll have more knowledge. Older, you'll be wiser, so you'll be able to do it. Okay. So don't get stuck on a question and try and do it forever and ever. Okay. Then we have this question over here. Okay. We have this question over here. We are told that use the compound angle identity that to derive a formula for cos of x plus y. So you're given cos of x minus y, and they want you to prove, they want you to find, make an identity for cos of x plus y. We already have that in our formula sheet. We have this, right? We already know what it's going to be here. But they're saying, ignore the formula sheet. We don't want you to use the formula sheet. Assume this is all you have. And you need to make a formula sheet for, you need to make a formula for cos of x plus y. Okay. So first you need to say, okay, I'm given cos of x minus y is equal to cos of x cos of y plus sine of x sine of y, right? But this one has a plus in the middle. Okay, maybe I can rewrite this part as a positive, right, with like a plus. Okay, maybe I can write it as cos of x. Oh, sorry. Oh, no, sorry. Maybe I can write this cos of x plus y with a minus in it. Sorry, do it the other way, because this is the formula that we have. Okay, so let's write it as cos of, so I'm rewriting this as rewriting this, cos of x minus y. Because we have the formula for cos of something minus something, right? But I'm gonna just, I'm rewriting this in terms of something with a negative there, because I know that if I have a negative, then I can write this with whatever the angles I'm given. So I rewrote cos of x plus y in terms of cos of x minus y. It's still the same thing because I can multiply this negative in and it'll give me cos of x plus y, but I want it to be a minus because my formula here has a minus. So I need to be able to, I want to rewrite this with a minus still, but a change in this angle. Okay, let's see. If I'm using this formula, I'm going to write it as cos of x cos of minus y plus sine of x sine of minus y. Okay, right? Now this part is fine. This part is fine, but these negatives, I need to find a way to rewrite those. Okay, cos of negative y. What is that saying? Let's say I had cos of negative 20, right? Just normally, and they asked you to write this as a positive angle, whatever, right? Cos of negative 20 is somewhere here. And we know that if we're ever dealing with a negative angle, I need to make it positive. So I need to make it cos of, I need to add 360 minus 20 plus 360. so that it would be a positive angle, right? But it would still end up in this cos realm, right? So this ends up with being cos of 360 minus 20. And we know that this quadrant is 360 minus theta. And so because cos is positive in this quadrant, this just ends up being cos of 20, right? Because when we simplify it, when we reduce it, it just becomes cos of that angle theta. So it'll just be cos of 20, right? I want to do the same thing here. So I'm going to say cos of negative y would be somewhere here. But I can't work with negative angles. I need to add 360 to this. So this would be cos of 360. Cool. This would be cos of 360 minus, or 3y minus y plus 360. That's what it is. Minus y plus 360, which is the same as cos of 360 minus y. Cos of 360 minus y, right? And we just said that this is cos of this quadrant here is 360 minus theta, right? Which is what we have, 360 minus y. So this would be equal to cos of y. So we've just proven that cos of negative y is the same as cos of y. Cos of negative y, we add 360, we move the 360 to the front, it gives us this quadrant here, which just gives us cos of y using reduction. Okay, now let's try the same for sine. Sine of a negative number, if I had sine of minus 15, I can't deal with a negative angle, right? I'd have to add 360 to it. So I have to say sine of minus 15 plus 360 so that it goes to a positive angle, right? So I'd have to say sine of 360 minus 15, right? And this quadrant, 360 minus something, is here, but sine is not positive in that quadrant. So it's going to have to be negative sine of that angle. It's negative sine of 15, right, when I use reduction. So if I have sine of minus y, can't have a negative angle, so I need to add 360 to this. So sine of minus y plus 360, right? And so I can move that 360 to the front. So sine of 360 minus y, which is in 360 minus y is in this quadrant. And sine is negative in that quadrant, so it's going to be negative sine of y. So we've just proven that sine of a negative angle is equal to negative sine y. Okay, so now let's put that into what we have here. We were here. We had just rewritten this as a cos of, oh, sorry, no, we're here. We've just written this as cos of a negative angle, or like this is cos of x plus y. We wanted to rewrite it as a negative here because that's the identity we were given. So now we can write it as cos of x minus y, which is basically cos of x plus y, is going to be equal to cos of x, cos of negative y, we said it was cos of y, and then sine of x, or plus sine of x, and then sine of negative y we just found to be minus sine y times minus sine y, which means that this is going to be equal to cos of x, cos of y minus sine of x, sine of y. Okay, and that agrees with the identity that we already have in our formula sheet that says here. This identity in our formula sheet says, let's move it to the side. This identity in our formula sheet says, what does it say? Yes, cos of, let's just move down. our formula sheet says that if I have cos of something plus something, it's going to be equal to cos of that first angle, cos of the second angle, minus sine of the first angle, sine of the negative, the sine of the other angle, which is which we used this trig identity to get to that. Okay, so this one is another. I lied when I said at the beginning that trig is simple. Trig is simple if you know what you're doing. This is how we would use an identity that we are given to prove another identity. You have to rewrite what you're being asked as if you were using the identity that you are given. So we rewrote cos of x plus y as cos of x minus y, which is the same thing, but because we know this formula, we could substitute in the values or the two angles that we got as x and minus y, and then simplify like that. Okay. Okay. Then we have, oh, hence or otherwise show that this. So because they said hence or otherwise, that means that even if you didn't get it, whether you got it or you didn't get it, you can still do this next question. So we want to show that f of x is equal to square root of 6. Oh, we want to solve for the interval for x. We want to solve for x in the interval from theta equals from 0 to 360 when f of x is equal to 2. We're trying to solve for x when f of x is equals to 2. So they've told us f of x is equals to 2. Did I skip a question? We went from 6.1.1 to 6.1.2. Unless it is a skip question. Let me check my phone. I don't think it's just skipped. I don't know why they put a 6.2 here. Ignore that. Oh, wait, unless I'm. Oh, I think this is two things. Oh, I did skip a question. Oh, sorry, guys. I just skip a question. Thank you. Thank you. Okay. I think I just moved it down without thinking. Okay. Hence or otherwise, so it does matter. Show that cos of 90 minus that is equals to tan that. So whenever you have a show that there's always a simple side that you can't do anything to, and there's a complicated side that you can do a lot of things to. In this case, tan of x plus y, you really can't do a lot. You don't even have tan identities that will allow you to use tan of x plus whatnot, right? So you have to use the other side. We're going to use the other side to try and prove that these two sides are equal. Okay. Let's see. So we can usually do a reduction or cofunctions or stuff like that. But hence or otherwise means that we have to use some stuff. I see here sine of negative y, and I also see, I see sine of negative y, and we proved just now that sine of negative y is going to be equal to negative sine of y. So maybe you're going to have to use that somewhere. Okay, yes, but let's do reduction first. So we've got here left-hand side is cos of 90 minus x cos of y plus sine of negative y cos of 180 plus x all over a cos of x cos of 360 plus y plus sine of 360 minus x sine of y. Okay, so it's just going to be a bunch of reduction and cofunctions. So let's see what we can do. So first one, I see it as a reduction. It's going to be one of those reduction angles. And to tell whether it's going to be a weird one or normal, and you can draw your graph, your Cartesian plane, and you're going to look at this is 90. 90 minus x lands here, and that's positive for both cos and sine. So this is going to be positive sine of x, because that's a cofunction, and then cos of y. And then we said sine of a negative angle is equals to negative sine of that angle. So this is going to be, it's going to end up being minus sine of y. And then cos of 180, actually, let's make it a plus here and then just leave it on minus there. Cos of 180 plus x, this is 180. This is 180 plus x. Cos is negative in that quadrant, so this is going to be negative cos of x, right? All over cos of x, cos of 360 plus y. So 360 is here, right? So we've gone 360 and then we add a little bit. So that's just still in the first quadrant. So that just stays as cos of y plus sine of 360 minus x. 360 is here. 360 minus x lands here. So minus x is here. Sine is negative in this quadrant. So it's going to be minus sine of x and sine of y. Okay, so that was just a bunch of reduction and cofunctions. And then we've got, now let's rewrite the sine of x, cos of y. This is a minus here, there's a minus here, so that just becomes a positive, right? Negative, negative, plus sine of y, cos of x, all over cos of x, cos of y, and then this is a minus here, so that's going to go to the front. So we're going to have negative sine of x, sine of y. Okay, this is compound angles, right? First one is which one is that? That uses sine cos and then sine cos. So sine cos, and there's a plus in between, so it's going to be this one. So it's going to be sine of x plus y over, and then the second one is cos cos and then sine sine. So cos cos, sine sine, it's one of these two, but we have a negative in the middle, so it's going to be this one. So it's going to be cos of x plus y. And we know that there's another identity that says sine theta over cos theta is equals to tan theta. So here we have sine of the same angle over cos of the same angle. So that's going to give me tan of x plus y, which is equal to the right-hand side. Okay, so that is how you would do that one. This one, I love this one because it means that I just need to do a bunch of reductions and I really don't have to do proving is like, I feel like it's one of the easier trick questions because you have a complicated side and you know that it's going to end up being like something like this. So you just have to work at it enough to get it to being like the right-hand side. Okay. Perfection. Okay, now the correct one that I didn't skip, that I wasn't going to jump to. I was just so excited to be. Oh no, sorry. I was just so. Did it stop? It did. My bad. Sorry, guys. I stopped sharing. Okay. We have. They were right. Yeah. Okay. Then we have. Scroll down. Okay. Then we have this question that says, given that f of x is equals to the root of sine squared x minus cos of minus 11 cos 90 plus x plus 7, we want to solve for x. We're basically solving for x in the interval between 0 and 360 if f of x is equals to 2. Okay, so we already told that f of x is equals to, this is basically a solve for x, but yeah, this is basically a solve for x, but they add a little extra element so that you guys panic a little bit, but we don't have to panic. So I'm going to put in f of x is equals to 2. So 2 is equals to the root of 6 sine squared x minus 11 cos of 90 minus x plus 7. First thing I notice is this 90 minus x. We never like leaving things in terms of these kinds of angles. So that is going to be a reduction angle, right? And it's going to change to being 90 minus x. This is 90 minus x. This is going to be positive sine of x. 2 is equals to root 6 sine squared x minus 11 cos, oh, sorry, plus x. Sorry. Yes, you're right. This is here, and cos is negative in this quadrant. My bad. Sorry, guys. Cos is negative in this quadrant, so this is going to be negative sine x. This is going to give me minus sine x. Yeah. So this is going to be a negative sine x plus 7. Okay. Then I'll have, I don't like the square root. I'm just going to square both sides. So square. So this gives me 4 is equals to 6 sine squared x. Now I have a negative and a negative plus sine x plus 7. Ooh, I see a trinomial forming, right? So this is a trinomial, basically. I'm going to move this 4 to that side so that we have a nice looking trinomial. Now I have 6 sine squared x plus sine x plus 7 minus 4 is going to give me 3. Yes, sorry. Okay, there's the 11. It's back. Okay, right. Now I don't like the fact that this is sine. So let sine x equal k. So 0 is equals to 6k squared plus 11k plus 3. Okay. Let's try and solve this trinomial. So we have here, we look for the factors of 6, 6 and 1, or 3 and 2, and the factors of 3 are 3 and 1. And we're trying to get to 11. Let's use 3 and 2 first. This gives me, that's not going to work. Let's try it the other way around. This gives me, let's try 1 and 3. This gives me 9. This gives me 2. I can get to 11 with 9 and 2 by saying plus 2 plus 9. That gives me 11. So this will be a plus and this will be a plus. This is x and this is not x, sorry. That's the constant. So my two brackets are going to be, from here, I'm going to write as 3x plus 1. And the other one is going to be 2x plus 3. So I said 3x plus 1 and 2x plus 3. Okay. I think we're all tired. I think we should just give Rutendo some grace. Okay? It is k. So 0 is equals to 3k plus 1 or 2k plus 3. Right. Ignore this. I was just dealing with texts. Okay. And so now we've got that k is either equal to, let's just do that. K, oh, sorry, not k. 3k plus 1 is equal to 0, or 2k plus 3 is equal to 0, right? And so 3k is equals to minus 1, and so k is equals to negative 1 over 3, or 2k plus 3 is equals to, or 2k is equals to minus 3, and k is equals to minus 3 over 2. And now we can substitute in back our sign. So remember we said let sine x equals k. Now we'll get sine x is equals to minus 1 over 3, or sine x is equals to minus 3 over 2. Now we are asked to solve for specific values of x within this interval. So we're looking for specific values of x. So this turns into a general solution question, right? So first, let's find our reference angle. Let's start with this first one. This x is equals to, sine x is equals to 1 over 3. So we've got our reference angle. We would just do shift sign of this 1 over 3. You'd put it as 1 over 3, not negative 1 over 3. And you should get 19.47 degrees, right? So that would be our reference angle. And so my x is equal to, this is where we're looking for quadrants where sine is negative, and that's in this one and this one. So the third quadrant and the fourth quadrant. Okay, I don't know which direction. Right. So in the third quadrant, it's the reference angle. It's going to be equal to 180 plus the reference angle, right? Plus K 360, or and the other one is going to be 360 minus the reference angle plus K 360, right? Let's see. My reference angle here is going to be 19. So what is 180 plus 19.47? That's going to give me 199.47 plus K 360. And then this is going to be 360 minus the reference angle, 360 minus 19.47. That is going to give me 314.53 plus K 360. Okay, now we are still working with the range. They told us that our range for x has to be between 0 and 360. So let's look at what values lie between 0 and 360. Oh, and they said round bracket, right? Let's see. They said round bracket 0 and 360, so it shouldn't include 0. Okay. If we make k equals 1, k equals 0, that'll give us an x value. So I'm just going to write all my x values. X equals 199.47, right? If k is equals to 0, then that works. If k is equals to 1, it's way beyond our 360, so that doesn't work. If k equals to minus 1, that's also way beyond 0, so that's going to not work. So the only value we can put in here is k equals 1. That's our only value we can put here. And then for this third one, if k equals 0, we end up with 340, so that works. 340. If k equals 1, it goes way over. And if k equals minus 1, that also goes way under. So this is also only one angle. Is this one possible? Can I find a reference angle for that? No, we can't. So this one has no solution. So if you can't find the reference angle, then we have no solution. And so your two answers are going to be x is equals to 199.47, or x is equals to 340.5. Again. So that was what that question was saying. Okay. And then I think, yes. Then we have this question over here that says, calculate the maximum value for G. We always use 360 except for tan. In tan, we use 180. Yes, we use K360. In tan is K180 because the period of tan is 180 degrees. Okay. And then we've got this question. What is the maximum value for G? Right. Now, this is a very interesting question. It might feel like it's a calculus question, but this is paper 2, so there's no calculus here. You can use calculus if you want to, but I don't think you guys have learned the derivative of sine, so you wouldn't be able to do calculus here, right? So we have to find another way. Let's think about it logically. The maximum value that G can be if we're given 4 minus 8 sine squared x over 3. How can we make this value bigger? Right. So the only thing we can change here is my x. That's the only thing we can change, or my sine x. That's the only thing we can change. We can't change 3, and we can't change 4, and we can't change 8. So we can't do anything to the denominator to make this fraction be bigger. We can't do anything to the 4 to make this fraction bigger. So maybe if we could increase 4, then that could make this fraction a bigger number, and then we could find a maximum of maybe infinity because we could just increase it forever. What we can change is the sine squared x. We can change that to be something that is so small that it's not taking away from this 4. So if I have 4 minus, let's say 4 minus 3 over 3, right? That's going to give me 1 over 3, which is going to be so small. If I have 4 minus 1 over 3, that's going to give me 3 over 3, which is going to be 1. But it's bigger than this, right? And that's because I was able to get the thing that I'm taking away from 4 to be so small that it's making my fraction like as big as possible, right? So we want to make this sign as small as possible. If we make it, we want to make it as small as possible. You might say, okay, then let's just make it a negative because then we will have a positive here. Then we'll just keep getting bigger and bigger and bigger, right? But we can't do that because we have a sine squared x. Have you ever squared anything and gotten a negative number? It is not possible. You can't say even square of a negative number, -3 squared will give you a positive number 9. So we are going to try, I think the smallest we can make sine is 0, right? If we can make sine x equals 0, then we can, this is as small as it can go, then it'll be 4 minus 8 times 0 over 3, which will give us 4 over 3. This is the maximum that we can ever get, right? Because the maximum for this, the maximum that this could ever be is the lowest that the sign can ever be so that it's not taking away from that 4 is 0. That's the lowest it can be. It can't be a negative number because it's being squared, right? So this would be our maximum G value. This one is not a calculation-based question. It's like a thinking-based question. Yeah. You could have also broken this sine squared down into something, but you just have to think about it logically. So this one is a bit like less about calculating and more about just like thinking through a question. Yeah. So in this case, because the lowest we can make sine is 0, which would give us 4 minus 8 times 0, the maximum is this. So this was more of an explanation type question and not a calculating question. Okay. If you could do calculus, then you could have done calculus, find your derivative and make it equal 0, and then you'll know what the point is where you can make it 0. But in this case, okay. The interesting method is to take out a common 4, right? If you take out a common 4, but this is like you have time to think about this. If you take out a common 4, you'll have 1 minus 2 sine squared x over 3. This 1 minus 2 sine squared x over 3 is a identity that you get in your formula sheet. I'll just tell you it's equals to cos 2x. It's one of your cos 2x ones, right? So this is equal to 4 cos 2x over 3, right? Now, the lowest cos 2x can be is 1. If you draw a cos function, right? Normal cos function looks like that, right? With the maximum at 1 and the minimum at 2, or the minimum at -1, right? If you scale it up, so now it's a cos 2x function, it's not going to be double the size. The amplitude is going to be double, right? So now it's going to be like that, right? No, the lowest it can be is not 0. Hmm. Hold on. What is the maximum of this? That's now 2. No, sorry. I don't know this method. I didn't look at this method. What is the max value for cos? What does the cos graph look like? Let me just get it out. Cos function. Because it might be a half. It's 1. Now, if we make it a cos 2 function, aren't we increasing the amplitude? And then unless, oh no, sorry. The highest, this is not, sorry, so ignore this graph. It's still a 1 function because your amplitude is still 1. Sorry, your amplitude is out here. The highest, it's still going to look like this. It's just going to look a little bit different, but it's still going to look like this. Maybe it's going to have a shorter period. It's going to be like narrower, right? Sorry, ignore this. I was mistaken. So the lowest or the highest this cos 2x can be is a 1, right? And so if this is the highest it can be, that means that the highest it can be is 4 1 over 3, which is just 4 over 3. Okay. So you guys don't know what the derivative of sine is yet. So you can't use calculus. Let's see. Derivative of sine. Unless you want to learn it just for yourself, just. But the derivative of sine x is cos x. So you'd find the derivative of this, but there's a squared. No, guys, that one's too complicated. They would never ask you that. But they would never expect you to do it like that. This one is more of a thinking question. But you could still do derivative of. But you guys haven't learned chain rule. There's so many things that you don't know to be able to use calculus. You won't be able to use calculus. Okay. And then our last question, unfortunately. Maybe we will have another lesson so that we can go through. You don't get the one part here. So actually, let me share my screen. Let me show you what that looks like before we leave. Okay, what is this? It's called Desmos. So there's this place where you can plot graphs, right? You can put in a function. You can put in like I want to see what this function looks like. And it's called Desmos, this place here. So I'm gonna name one of my graph f of x equals cos cos of x, right? That's a normal function. This is a normal cos function, right? It has a maximum value at 1 and a minimum value at -1. If I make another graph, g of x, and I make it equal, oh, is it blank? Can anyone else see? Can you guys see? Let me know if you can see that. Oh, maybe you can switch off and switch back on. But this will be recorded so you'll be able to see it if you watch. Okay. But let me, oh, like I've zoomed in now. This is a cos graph. That's the top of a cos graph, bottom of a cos graph. Now I make another function and I call it cos2, let's say, cos2 of x. It's still the same function. It's still maximum at 1 and minimum at -1. It's just now narrower, so it's got a smaller period, right? So instead of having a period of 360, where it goes down, up, then starts going down again at 360. Sorry, this is in radians. It's now narrower, so it's got a wave. The wave is much shorter, so it's going to have a thing of a period of 180 instead of 360. But it still has a maximum. Like the maximum it can be, the maximum cos2x can be is 1, right? And so what I thought before, let's say h of x, before I was drawing the wrong thing, and that would have affected the amplitude, 2 cos x would have been a double, would have given you a graph that's got a thing at 2, a maximum at 2. So that's what I was getting confused. But this doesn't, that 2 in our cos x, okay, so now I've showed you all the graphs. That 2 in our cos x, let me go back here. This 2 in our cos x, this 2 in our cos x just makes the period shorter. So our amplitude is still 1. So the maximum it can be is still 1. So the maximum this can be, this cos2x can be is 1. And so the maximum the whole thing can be is 4/3. Okay. Okay, so that was just for the maximum one. And then they said, write down the smallest possible value of x for which g will have a maximum value in the interval from 0 to 360. So we were told that g of x is equals to, what are we given? Is equals to 4 minus 8 sine squared x over 3. They're asking, what is the smallest, what is the smallest possible value that over 3? What is the smallest possible value for x, which is here, for which g of x will have a maximum value in the interval between here and here? So what is the smallest possible value for x? So how small can x be so that g of x will have a maximum in the interval of 0 to 360? Oh, we're looking for what is the smallest value x can be for our g to be, what is the smallest possible x value for which g will have a maximum value in the interval between there and there? Okay, so we said that our 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 maximum value will happen when sine of x is 0, right? And if we look at our sine graph looks like that. We want to know where is our sine of x equals 0. So what is the smallest value of x that we can get that will make g our maximum, which is where we said where sine of x is 0. So where will this happen? Between 0 and 360, but not including 0. What is the smallest value of x? We can see that it crosses here at 180 and 360, but the smallest value for where sine is 0 is going to be here. So they are asking from 0 to 360, where are we going to have g of x be a maximum? We said g of x is a maximum if sine x is equals to 0. And so where is sine x equal to 0? Where is sine x equals to 0 between 0 and 360? What is that smallest value is 180. So it happens twice, but the smallest one is 180. So this would be x is equals to 180. If it was confusing, it's okay. It was only 1 mark. But now you know. If it comes up, then you know how to do it, which is always very encouraging. Okay. Okay, so we are at 8 o'clock. We may arrange another session just so we can finish this little bit of it. But thank you guys for joining. We just had 2 more questions to do. So we just had question 7 and 8 to do. And yeah. Oh no, 7, 8, and 9. Okay. But yeah, I hope this was helpful for you guys. At least now you know all your trig. That was all the trig that you were supposed to learn, and maybe trig graphs. Yeah, so I hope this was helpful. Thank you guys. Tomorrow there is physics part 2. So I think they're doing chem. Um, we are doing the second part of that paper. So there was, we did on, when was it? On Wednesday, yes, we did the first part of paper 2 for physics, and tomorrow we're going to finish off with the second part of paper 2. Yeah. Okay. So if you guys are doing chem, you can join that one as well. Thank you guys so much for joining. Thank you for participating. Um, we have a little website, well, not a website, but if you type in the learning space on Google, you can leave us a review and say, oh my gosh, the learning space is so nice. Everything makes sense. And then you can just leave us a review there. But also have a WhatsApp group, a WhatsApp channel, YouTube, so you can go and look for all of these resources on there. Yeah. Okay, perfect. Thank you guys for joining. Have a good evening.